Okay, so till date, we have discussed about the various features what F5 can deliver, what all things that we can configure. Now comes the best part, which is troubleshooting the F5. Whenever you are trying to troubleshoot any issues related to be it any product, not only with respect to F5. So basically, your approach towards the problem should be first to understand what is the problem. Once you understand the problem, try to gather information related to it. Then develop a specific plan which you want to implement. Implement the plan. Then check the results. And again, rinse and repeat it until you find what exactly is the solution. That should be your approach. So in this section specifically, we will discuss about the logs. We'll discuss about SNMP, setting up SNMP and traps. We'll discuss about iHealth. We'll discuss how we can use analytics profile to gather the data. We'll see how do we capture the packets on the device. We'll try to understand what is EUD, and then at the end we'll see how do we contact the vendor. Now, so first of all, there are three different logging methods. First is your Linux syslog ng, which has an option for local logging. Then Linux syslog ng, which is remote logging. And then we have a feature called as TMOS. Within TMOS, we have something called as HSL. HSL stands for high speed logging. So basically, any event that happens with the device, there are different log levels of messages which get logged. Let us try to understand what are these different log levels. Emergency, alert, critical, error, warning, notice, info, debug. So these are various possible options for the levels of logs which you can find in your device. And from a verbosity perspective, how detailed these logs are, you can think of this as maybe medium, this as low, warning is medium, high, and maximum. When you set this to debug mode, everything, whatever happens with the device, gets logged. Emergency log levels would be some emergency system panic messages. Alert level would be serious errors that require your intervention. Critical errors are in errors including hardware or file system failures. An error is like non-critical but probably very important messages. And warning is something which should be at least logged for review. Notice is something that contain useful information but can be ignored. Info is again useful information and can be ignored. This specific option is moreover required for only troubleshooting. Ideally, none of the options will be set as debug, because this again is resource consuming. So by default, whenever we talk about the different log facilities, all the logs on the device, basically you would find that in, let us see if the device is up. So let me show you. Okay, system is still getting up. Fine, no problem. By default, all the logs will be stored in var log directory. So anything that you are trying to troubleshoot, you have to come to this directory to see various files. And in this, we have different log facilities. The facilities are local 0, local 1, local 2, local 3, local 4, local 5, local 6, local 7, and apart from this, other log facilities are also there. In specific, this log facility is something which logs big IP specific messages. So any event which happens, like your virtual server going down, pool member flapping, monitor is failing, all these logs you can mainly find in this specific facility. And the location of this facility is var log LTM. Then local 1 is corresponding to majorly EM and APM. These are different products of big IP or F5 device. So for EM, the location is var log EM file. And for APM, the location is var log APM. Local to facility is mainly for GTM. GTM and any link controller message specific messages will get basically logged here. So in here you have to go to var log GTM. Local 3 is corresponding to ASM. For this, the location would be var log ASM. Local 4 is mainly for I control specific messages, And again, for this also, the location is var log LTM. Local 5 is for packet filtering. For this, the location is var log pkt filter. Local 6 is for mainly HTTPD process, and for this the location is var log httpd underscore error. And local 7 is mainly specific to your boot messages. For this, the location would be var log boot.log. So mainly whenever you are trying to troubleshoot any specific issue, you have to understand what is the problem related to. Is it related to LTM, related to GTM, related to ASM, APM, anything? So according to that, you mainly have to focus on that specific log file. Now, let us see. Let me check if the device is still up. Is it still coming up? So basically, whenever you log into the command line interface of the device, you would have to change your current directory to go to cd var log, and in here, if you do ls, you will find all the different files related to different facilities. And for each file, there are different variations to it. So like if you consider LTM file, for LTM there you might see LTM, LTM.1, LTM.2.3. Like this, you'll find different specific files. So these files basically provide you a way of managing the log files on the device. So by default, there is a script which rotates the log file, which is called as log rotate script. And the default value for storing the data for the number of specific days is basically decided by log rotate dot log age. This is the main database variable which controls for how many days the log files will be stored, or at after how many days the log file is eligible for deletion. So in order to check the value of this specific database variable, what I do is I need to go to my tmsh prompt and do list sys db log rotate dot log age value. The default value for this variable is 8. So it basically stores logs for those many days. And if you want to modify this parameter, the command which you use is modify sys db log rotate dot log age value, and then whatever value that you want to give. So by default, this is the legal value which is available. You can set this to from 0 to 100 days. And after modifying this parameter, again, you need to save the configuration. So you just type save sys config. This is very much important. And the number of archive copies that the system retains is basically decided by the value of parameter which is log rotate common backlogs. So again, to modify the value of this specific parameter, you would follow the similar command: modify sys log rotate log common backlogs value, and then give enter. And again, for this also, the legal value is from 0 to 100. You just save this configuration after this. Let us see. Now the device is up. It is still coming up. In order to open a specific file, you would use the command less and then the name of that specific log file. So less LTM, if I give, it will show me the contents of that specific file. What is actually happening? Maybe a virtual server going down, virtual server coming back up, power supply failure, hard disk failure. Anything that happens with the device basically would get logged into this log file. So based on your timestamp, when the issue started, or when, if the issue is intermittent, you can check the log file as per your date. So basically in here, when you do ls space minus l and then do a grep for LTM, you would see the different files. So basically in this, what I have done is I have listed the files, and this list file I have given as an input to my grep command, and I have instructed grep command to find in this list the output of this command. In this output, I need to find grep LTM. So basically it will list me all the LTM log files. So as per the date, whenever the issue is occurring, if maybe the issue is intermittent, if let us say that the issue had occurred on 22nd, so you might open up this specific file, or maybe one file before or one file after. You would have to concentrate on these specific log files to understand what has happened during that time. This is not coming up. So basically in here, you will find different log files related to packet filter. You will find the PKT filter file related to audit. You will find audit files related to kernel. You will find kernel log files related to any issue related to TMM itself. So you will have specific TMM instances files. All this you can find out. Then whenever you are trying to troubleshoot, and you also want to find the specific contents which are being written as and when live traffic is going through the device and whatever is happening. So basically I would want to check the live entries of a specific file. In that scenario, you can use a command called as tail and give the file name. So var log LTM. So basically what it would show is, it would show you the complete or current contents which are being written in this log file. So as and when it is being written, it will show you on your screen itself. It's not coming up. It's taking a long time. So basically all the system log files which are getting generated can be sent to alert daemon. Alert is one specific process which runs on the device which takes specific action when something happens. So who has to be alerted? Maybe a trap has to be sent or email has to be sent. So when LRD receives the input, it can either send a or initiate a email alert or a SNMP trap. Or these log messages can be sent to local log files or your remote log servers. I actually wanted to show how the logs are seen from the graphical user interface as well. This what I've shown now is from the command line interface. So basically you log into the device, you change your current directory from current to var log, and then in there whichever log file you want to view, you can do a less, and in there you can try searching for any specific entries. Maybe you are trying to find out when a specific application is going up or down, so you can filter with the name of your application or with the IP address of your application to see logs with respect to that. Now that we have seen this local log files, we can also, it is ideally not feasible for us to store all the log files on the device itself, because again it is going to take memory space, consume CPU cycles to store and move the data from one place to other. So for that you also have option to configure your remote syslog server. In order to view the configuration of your syslog server, again you go to TMSH mode and do list syslog. Or in order to add any syslog IP addresses, remote servers, you can do it either via graphical user interface or from command line interface. So from let the device come up, then I'll show you how it is done from graphical user interface. And this CLI interface, basically what you do is you run a command, similar format, tmsh modify syslog remote servers, add, then give the name of your syslog, maybe my syslog 1, and in here you have to mention your host IP address, let's say 10.10.1.100, and what is the remote port. So this is a way in which you can configure your remote syslog server. Let me see if it came up. Okay, this is up now. So after logging to the graphical user interface, you go to main and system. In system, you will have an option for logs. Click on logs. In this log, you'll find different options. Like this is where you can see the log level, notice, and what service is actually has triggered this log, and what are the event details. So this is how you will see any specific log. Similar thing I can also see from the command line interface. Again, I change my directory, and then I do ls. This ls will show me all the log files which are present on the device and various instances of those log files. So if I am trying to troubleshoot any issue related to LTM, I would just do ls space minus l and grep for LTM. Then do less LTM file. Like this, from you can see if analytics is enabled, you can see any captured transactions which are going through this device in here. You can see your packet filtering logs. You can see your local traffic log. Anything related to GTM will be logged in here. You can try and search for your audit logs. Then in here you have the configuration settings. So you go to options tab. So here you will find the various entries or the log levels. So for each protocol, what is the log level for that protocol. So maybe for HTTP, the log level is error. If you want the information even at a deeper level, you can just do a drop down and change it to the debug level. So for not for all protocols, all levels are available. So if you are trying to do anything related to network, probably you will get all these different options, but when I am selecting this, I am not getting any other option. So either it is error or it is debug. So you can set it up as per your requirement. If you are trying to do some debugging on the SSL, you can just select this and choose it to debug. But before doing this, always get a consultation from the vendor, because enabling this might also trigger more load on the device, and if you are trying to do this on a heavily loaded device, it might impact the performance of the device. Then from here you have a different types of administrators, and whether they will have access to the log files or not, that you can define in here. So deny means this type of user will not be able to access logs. So if you want that to be changed, you can change it here. Next, this is all about local logging. So if I want to configure my remote logging, I select this specific option, just enter the IP address and on what port it is listening and click on add. Just update. That's it. And similar to this, when I want to see my configuration from the command line, I would go to team message mode, and do list sys syslog. Again, for modification, we can follow the same process. Modify syslog name, then whatever we want to add. Now, this we have talked about is our local logging and remote logging. So the main two methods which we had discussed earlier, we have completed now. Next option is HSL. So let us try to understand the HSL process. HSL stands for high speed logging. So there are some specific scenarios wherein I directly want all my log content to be written over a remote server, and that too I want a specified filters, maybe any logs generated from some specific process. I want only those logs. Any logs generated with a specific message ID, I want those logs. So all this basically you can configure in your HSL. Now let us try to understand how do we actually configure our HSL. So first of all, we'll have a log profile or log filters to specify what log files I'm trying to filter, and this we send it to our publisher, and from this publisher we can create or send the logs in some specified format. So maybe if your remote server is a ArcSight appliance, or is Splunk, or is of the type of remote syslog, you can choose the specific format so that messages basically appear in that format. So these are your formatted log destinations. And from here, it goes to your remote high speed log destination, which you create. This basically sends it to a pool of remote log servers. It could be one server, two server, or three server. These are a pool of remote log servers. So let us try to understand the processes which are actually involved in configuring HSL. First is you define a specific pool of servers. After this, you define your HSL destination. Then you define your formatted destinations and then define your publisher, and at the end you define your filter. Let us go see how do we configure this one by one. So in here, first what you do is you have a set of servers which you are planning to use as your remote log servers. So you introduce those IPs on the specified ports as a pool. So basically you go to local traffic, pools, pool list, and here you create your new pool, something similar to, let's say this. I choose this which I have already created, and in this you add the members, whatever IP addresses that are that will be acting as your remote log servers, all you can add it here. So our first step is done. We have created a pool of remote log servers. Now what we do is we create a high speed log destination. So for that we have to go to system, logs, configuration, and log destination. Click on create. Give it a specific name, high speed destination, and from this type you select it as high speed remote high speed log, and then in this pool name you select the pool which you have created, the list of pools, the list where your actual servers are present. So I had created HSL pool, and this protocol you can choose it to define how these logs will be actually sent using what protocol. And this distribution method, there are three methods which you can choose from. So by default, if first it is selected as adaptive. In adaptive method, what happens is the F5 will select one of the pool member from your HSL pool, establishes a connection to it, and send all the log traffic to that remote server until the rate of HSL traffic exceeds what the remote log server is capable of handling. So let us try to understand this. So basically, this step is done. We are at this step now. Let us say we have these three log servers, and this is our F5. This is remote server 1, remote server 2, and remote server 3. So when I choose my distribution method as adaptive, in this what happens is from F5, connection is established to your remote log server. Basically, it chooses one of the servers from the pool and then keeps sending all the log traffic to that remote server until this remote server is maybe not capable of handling the rate at which the logs are being sent, or this connection for some reason breaks. And when this happens, basically F5 will choose the next pool member from your HSL pool, establishes a new connection and sends rest of the HSL traffic to this remote server. This is in case of adaptive. Now, when you choose balanced, in case of balanced, basically F5 would direct the logs to these servers by picking up the pool members as per defined in the load balancing method. So every time F5 is attempting to send a log file, it will see what is the pool member load balancing method configured there. It will choose one of these and then send it across. Then when you choose as replicated, it basically means that you are using one of these servers as your primary log server and one of other servers, for example, as a secondary log server. So basically what happens is, in this case, logs are sent to all the servers. So basically you are trying to create a redundancy in terms of having your log files. You have the log files here also as well as here also. So all servers in the pool, whichever are configured in the pool, will have the logs. When you want it in that way, you have to choose it to as a replicated in your HSL destination. So let us say I choose this to adaptive and click on finished. So now after I create my remote log destination, which is in the format of HSL, I also would have to define my formatted log destinations. So again, I go to system, logs, configuration, log destination, and in here I click on create, and from this type I choose one of the specified formats, maybe ArcSight, IPFix, or remote syslog, Splunk, anything. Let's say I choose it as Splunk, and in this specific option from the forward to list, I would want that the destination points to my local pool of high speed log servers to which I want the logs to be sent. Then give it a specific name and just click on finish. So after I have basically created my remote log, remote HSL destination, formatted HSL destination, then what I do is I create a publisher so that it can publish the logs to these destinations. So again, I go to system, logs, configuration, and then I go to log publishers. From this log publisher, I click on create. I define any specific name, whichever I want to create. Then in the destination settings, I basically click and move all the selected destinations. So for example, if you, for a formatted destination, the destination that matches your log servers, such as it could be syslog, Splunk, ArcSight, just select this and move it this side and give it a specific name, click on finish. So after this publisher is created, then at the last, we define our logging filters. So in here, I go to configuration and log filters. I click on create. I give it a specific name. And then this is my basically filtering criteria that I want logs of what severity. I want logs which are generated from what source. I can choose some specific process. So if maybe our process generates any logs, I want those logs. If Big D process generates any logs, I want those logs. Anything, it could be anything. Or if you want everything, you can choose all. You can also check logs or get any specific logs of some specific message ID. That message ID you can enter it here, and from this log publisher tab, select the log publisher that you created and then just click on finish. So that's it. Your configuration with respect to HSL is also done. Now let's come to discussing about SNMP. Whenever we talk about SNMP, basically in any infra, we would be having a SNMP manager, and from your device perspective, this you have a process called as alert-D. Alert-D basically generates all your traps, and in here you have a SNMP agent which you have to configure, which would respond to the queries initiated from this SNMP manager. So this is called as polling. So proactively asking for some information will be called as polling, and proactively F5 sending a trap to the remote destination which we have defined will be called as a traps. In SNMP protocol, we have something called as MIBs, management information base, and these MIBs basically have OIDs, object IDs. So MIB is nothing but a collection of OIDs. OID is nothing but a parameter related to any option. So for example, for CPU, you might have a OID. For memory, you would have a OID. For interface usage statistics, you have a OID. So like this, there will be different set of OIDs, and collecting which a MIB is formed. These MIBs are what is loaded in your management SNMP manager, so that it knows what is the object ID that I have to ask for in this poll information. So your SNMP agent basically responds back with that information. If the manager asks what is the CPU usage now, it would send information that at present it is 4%. So something like that. And alert D is something when there is something which happens with the device, a issue which has occurred with the device, and F5 would like to inform its remote end that boss, there is some problem with me. You need to have a look at it. So now let us see how do we configure SNMP on the device. In here, you go to main, system, and you come to SNMP tab. As in agent, select agent and click on configuration. So whenever we talk about SNMP, there are different versions: version 1, version 2C, and version 3. So version 3 is the most secure SNMP protocol version. In some environments, you might find V3. In some environments, you might find V2. So you have to know how to configure both. And whenever you are configuring V2 on the device, you would have to configure similar on your SNMP manager as well. Otherwise, the communication will fail. So first of all, this device being a part of your network, you need to ensure that it does not give away the critical information about the device to anyone, maybe from asking from outside. A hacker which comes in and he's trying to get some information of about the network, he should not get any response from this device. So that is wherein we first define our SNMP access. So from which client list or set of IPs that this device will respond back. So you have to add the IP address of your SNMP manager here, or whichever device is basically doing the work of polling. Then from here you click on version 1 or version 2C and click on create. So you basically have to define your community string and what source that community string will be used from. OID you can leave it blank, and what is the access that you want. Is it read only or read write? So anybody with the source IP address initiating a communication, what he can do? Is it, can he do only read only task or read write task? You can set it up as per your requirement. And in the community you define basically a way to authenticate a string. Any string you can define as per your requirement, and then just click on finish. Similar to this, you also have an option for v3. So basically click on v3 option and then click on create. So in here, if you see, whenever I try to create a record for SNMP v3, you will have to fill in all these details. Authentication, what is the method that is going to be used, what is the password. For privacy, what is the protocol that is going to be used, what is the password. And again, access level is read only or read write. All these things you have to set up here first. And from this traps section, you click on the configuration. You see for agents start stop, it is enabled, trap is enabled. Device, if it goes, there is some any problem with the device, it will start sending a trap, it is enabled. And then in this destination section, you just choose the destination section and define your trap receiving server. So basically you click on create, select what version do you want, version 2C or version 3. Based on that, you would have to select, configure the parameters. What is the community? What is the destination IP address? What port it is? And choose the default or maybe the management port through which it is trying to communicate to that IP address. And then just click on finish. So this basically completes our log, understanding logs and how do we configure SNMP on the device. Now, next important thing is you might get some scenarios wherein you want to create your custom traps. So by default on the device, all the alert configuration would be on this specific file /etc alert d alert.conf. This will have your default traps configuration. If you want, it is recommended that you do not modify this specific file. If you want to define any custom traps, you can, there is another file which is provided, and that file is, the location is /config /user underscore alert.conf. This is the file where user defined traps are mentioned. So basically, let us see now how do we actually configure this SNMP traps, custom traps. So on the device, if I, let's say, In here, if I open up this file slash etc config, sorry, etc alert d alert.conf file. So this file will basically have the default entries and what action will be taken. So basically this alert, a CPU high temperature occurs. So for that a trap is generated as well as a LCD warning is displayed. What warning is displayed? CPU temperature too high. This you will see on the LCD panel of the device. Anything if MCFD process there is some error, you will find for the license validation you will get this specific error. Then in here, if you search for, see SOD, if there is a switch failover which happens, a failover standby is fails, then a trap is basically generated. So these are basic entries which are there by default. Now your requirement is whenever a specific event happens, you want a trap to be generated. So for example, what you do is you will review the log files. Let us say when you are reviewing this LTM log file, you found an entry for maybe March 16th, let's say some timing, LACPD process with some message ID and stating as switchboard fail safe. So now I want whenever this event basically happens, a trap has to be generated. So what I would do is in my config slash, sorry, user underscore alert dot conf file, I will create a alert. This alert will have my message name, the alert name, and what it has to match, the matched message. And then in here I just write one specific line, snmp trap. Traps also have some OIDs, so you give it a specific value, make sure that it is not being used anywhere. And this file is what you need to add in your this default configuration. And after you add this content, you just save this file and maybe restart the LRD process. You might also get scenarios wherein apart from this, you also want an email notification. So again, for email notification as well, you have to edit the same file with the entry So first of all, what I would do is I would use copy to copy this file, user underscore alert dot conf. I would copy this in a with a different name. So config user underscore alert dot conf dot maybe backup. Maybe if there are any entries in this file, I'm just trying to backup, take a backup. It is a good practice that whenever any event happens, if you want to revert it, you should have the backup file. Then basically I change my permission of this specific file so that I can write anything in this file. So what I do is chmod. Chmod is a Linux command used for changing the permission. So I use it to 644. And then I mention the path of the file. And in this file, I will give my alert name, SNMP trap OID, and I would also add my email to address where it has to be sent to. So for example, email to address equal to demo at f5labs.com. This is the email where the information has to be sent, and from address equal to root, and what should be the body of the message. So body is equal to test of solution worked, maybe just for testing purpose. Then you close this file. So you save this file and exit, and again revert back the permission. So again, to revert the permission, you would use chmod 444 and the name of the file. And after this, you will restart the LRD service. This LRD service has to be restarted. So use the command tmsh restart sys service LRD. That's it, you are done. So basically, whenever that specific event or alert is generated on the device, you will get a email notification. So this was about setting up SNMP on the device and how we can modify, create our own configuration, custom alerts on the device. Now, one of the most important things that we should know, that in terms of troubleshooting, whenever you are trying to troubleshoot, we should know how we take a packet capture on the device. Because in today's world, it is important to understand what is actually coming in, what is going out. So we basically use the command TCP dump on the device to perform packet capture. Let us try to understand this command. How do we actually use it? So first of all, in order to run this packet capture, we have to select an interface where I am trying to run this. So basically, I would use a specific log file. So how I would write this is TCP dump space minus I and then my option or value. So for example, if I want to perform a packet capture on one single interface, 1.1, I would use TCP dump space minus I, and then I type 1.1. Or you also have an option to run it on a specific VLAN. So in that case, you would use minus I and then the name of the VLAN. So for example, let's say I am trying to run this on internal. Or you want to run the packet capture on your management interface. So for that, the command would be minus I and eth0. But all these options are actually not feasible whenever we are trying to troubleshoot. If there is anything related to management interface which you are troubleshooting, probably you can use that. But you ideally, I would not know when a packet is actually arriving, whether it is taking 1.1 interface, 1.2 interface, or 1.3 interface. So in that scenario, I would take my packet capture using something called as minus I 0.0. This option you would have to use very carefully, because what it does is it starts the packet capture on all the interfaces on the device. So you cannot use this without any specific filters. So you have to have specific filters defined after this to perform a packet capture using this option. Now, by default, the TCP dump command, what it tries to do is it tries to look up the IP address and use names rather than the numbers. So for example, in your domain 10.1.1.2 is the IP address where with respect to which we are trying to take packet captures, or anything that is any packet which is coming from this. So instead of displaying this as an IP address, it would try to resolve this IP address, send a query to your DNS server which you have configured on your F5, and try to get a response. So this process again takes time, and sometimes the output might be confusing. So we don't want that. So in order to disable that, we use a flag called as minus "n". So basically I combine this with I and I type TCP dump minus "ni". N is for disabling the resolution for this IP address, and I is for interface, and then I type 0.0. After this, I have to basically, whatever data is being captured, I have to write it in a specific file so that I can read it later. So to write this file, what I use is I use a filter called as -w, and then I specify the path where the capture data has to be stored. So for example, I save it. I want to save this to my var temp location, and I give the name of the file as test.pcap. So basically this way, what I'm trying to do is I am trying to capture all the traffic on this interface and writing the contents of that capture with -w option in this file, and this file I would have to use in my Wireshark to read the packets. Now after this basic thing is done, we have to use filters to restrict the amount of data that I am trying to collect. because this way everything that is flowing through the device will be captured, and it will be of no use for me trying to troubleshoot any specific issue, because I might be troubleshooting issue related to specific application. And if I'm trying to capture, let's say, 1 million or 10,000 packets, out of which only 100 packets are related to my application, finding out those 100 packets in a set of 10,000 packets would be quite difficult for me. So instead of that, why would I not use specific filters with respect to my application? So let us see how this filters work. You can filter on a specific host. So basically you type TCP dump host and your IP address. So in this way, what is happening is this will capture all the packets that are traveling to this IP address or from this IP address. So for example, I would type TCP dump host 10.90.100.1, or if I want to capture only those packets where this IP address is mentioned as my source packet, so then I can use something like this: TCP dump src host and then my IP address. Or if I am trying to capture the traffic where this IP address is basically configured on as a, or is present as a destination IP address. So I would use destination DST host and then my IP address. This was about filters on a specific host. Now, apart from this, you can also use the filters on port. So in this, you will type TCP dump port and then your port number. So for example, if I type as TCP dump port 80, which means that this port, whether it is configured in a source port or destination port, wherever this port is mentioned in the packets, that packet will be captured. Now I want to view only those packets where the source port is port 80. That also can be done. I would use TCP dump so src port 80, or I can also do captures wherein this port is configured as a destination port. So I would use TCP dump destination port 80. I can also combine my filters with AND operator. For example, I can type sorry, I can type TCP dump host 10.90.10.100 and port 80. So this would mean that packets wherever this IP address is present and the port 80 is also present, be it on a source port or a destination port. Or I can also do filters like TCP dump, where the source host is this IP address and my destination port is 80. That also is one way of capturing. Or I can also type TCP dump source host 10.90.10.100 and my destination host 10.90.100.101. So where this is IP address is in the source and this IP address is in my destination, that packet will be basically captured. Now, whenever we use TCP dump, it basically tries to limit the amount of each packet which is captured. I would not want that. I don't want my packets to get truncated. So in that, to ensure that the packets are not getting truncated, I use a filter called as -s or snap length, you can call this. So after -s, you type 0 if you don't want any packets to get truncated. So basically you want to capture the entire packet. Or you can also use -s200. So for using this, what would happen is only the first 200 bytes of each packet will get captured. So basically same thing you can type using TCP dump -s200 and source host, let's say 1.2.3.4 and destination port is 80. Now similar to this, as I had mentioned, the TCP dump utility basically tries to look up the IP address and give us the name instead. Similar to this, it also tries to do a resolution for your port. So for example, if you are using port 80, it would represent that as HTTP instead of port 80. This again is a time consuming task. So we don't want that. So instead of, if I need both IP and port resolution to be overlooked, I use the command as TCP dump space -nn and then type source host destination port as 80. So this is for IP, this is for port. Now that we have understood the various options that we use, we can combine everything and type one single command TCP dump space -nni for IP, for port, and I for interface 0.0 -s0. This is to ensure that there is no truncation of the packets. Then let's say I try to capture using this IP address, and I am trying to write this in my specific file where temp test.pcap. Let us see and try to capture the traffic on the device. Uh, so what I do is TCP dump space NNI 0.0 host this IP address minus W where temp test1.pcap. This is the name of the file which I have given. Then press enter. Let me try to access this IP address. Okay, I tried accessing this. In here, I come to the command prompt. You do not see any information. You just do Control C. The moment you do Control C, you will find the output as 26 packets received by filter. So that means there were some packets which were written in this specific file. Now, before stopping, if you want to see whether packets were captured or not, basically you modify this command and include the verbose option. And then again I do a packet capture. Here, the moment you see I included the verbose option, I am seeing an icon for got 0. Let me try to refresh this page. I can see I got some packets, got 6. So here again I can do Control C. Now I got my packet capture file. This is my packet capture file. So basically you have to log into the device using WinSCP. So you enter the IP address of your F5 device. You enter the username, password. It will get authenticated. And now you are logged in. So you go to the root directory first. From here you go to var directory, because var is where you have saved the file. From where you go to temp directory, temp directory, and then from temp directory you will see that test1.pcap is the file. So this, you just try to move this to your desktop. After moving this, let us see if we have got the file. test.pcap is there, and you open this file in Wireshark. So basically you have to have Wireshark installed on your local system to view this file. So once I open up the file, I can see the data which has been sent from my client system. A SYN packet is sent. SYNAC, I got the SYNAC ACK, sent the request, and then got a reset. So all this you can do the capture and analyze what is actually happening. Where exactly is the issue? Why the application is not working? So this was about TCP dump. Now, whenever you're trying to troubleshoot any specific issue with a device, basically you don't have the access to the device. In many infra, you might not have access to the device. So you might be working as a tag support for the clients. So in that case, there is one specific file which you need to ask to the client. That file is called as QKview. QKview is like a zipped file having snapshot of your system. So basically at that point of time when this QKview is being generated, what is the status of the device? What is the status of various applications of the device? What events were actually occurring during that time? What was the CPU? What was the memory utilization during that time? So basically whenever we try to generate this QKview file, at the back end, it runs a set of commands, and these set of commands, we can see and view the output of each command from this file. So in the background, it runs all the show list commands and gathers the information related to the configuration of the device and the current status, and creates one specific file which is called as QKview. This file you can generate both via CLI as well as GUI. Let us see where do you generate these files. So from the graphical user interface, you go to, from main section, you go to system. In the system section, you go to support. On this support option, you can select your QKview, which is already by default selected. And in the support option, you also have option to perform packet capture. TCP dump, you can do it from here. But it might not be having all granular options. So it is always better to perform the captures from the command line interface. So in here, you select this option and click on start. So basically what happens is the process to generate the QKview is started. In the background, all the set of show list commands would be executed and one specific file will get generated. And this same command, same file, if you are trying to generate it from your command line interface, you just log into the command line and just type qkview and give enter. So basically that same file will get generated. Also do note that when you try to create this qkview file, uh, maybe on a heavily loaded device, if you try to run, it might increase the performance, or in terms of, sorry, decrease the performance of the device. So it might impact the performance of various applications hosted on the device. Usually it takes some time to generate this file, as um, it is trying to run multiple commands in the background and gather the information. Okay, while this QQ view is getting generated, let me explain how do we actually use this file. This file we use in order to analyze this file. We have a portal called as iHealth. It is the link is ihealth.f5.com. So with whatever ID that you have initially created on F5 website, you can use the same link, same ID to log into this link. Let me log in. So after you basically log in, you have to click on this upload section, choose the specific file which we are trying to generate from the device, download that file to your local desktop, and from this option click on upload, choose this file, and after the file is selected, just click on upload QQ views. Once you click on upload and that upload is completed, and you click on this find QQ views, you will see the QQ view of your device in here. You can see what version it is, when it was generated, when it was uploaded, all this data information you can see. So let us assume that this is our QQ view file. I click on this file. From here, I can get ample of amount of information with respect to that device. What is the host name of the device? What is the actual status of the device when the QQ file was created? It was active for about 21 hours, 51 minutes. What is the uptime of the device? What is the load on the device? What is the physical memory, CPU? How many virtuals are created? How many nodes are created? All this configuration you can see. There are quick links to the basic configuration files as well. bigip.conf, bigip_base.conf. This will have your all network related configuration. This will have your basic objects like virtual server, pools, snats, any iRoots that you create. All this you can find it in here. And you will have option also links for your log files. You can see what version is actually at present installed on the device, what is the module which is actually enabled on the device. All this information you can see from this icon. Not even this, you can even see the hardware on which this was created. You can see the specs. See, this is how a specific device would look like. Management port, USB, console, failover port. These are then TMM interfaces. Then here you will find the LEDs, LCD panel, and these icons. Then you can find the hardware specifications. What are the hardware specifications? What is the part numbers? Then comes the section of commands. In this command section, you can run various commands on the device. Basically, it is similar to when this QQV was generated on the background, there were multiple commands which were run. So basically, if I select this TMSH and I go to LTM, I want to see all my virtual server configuration. So basically, for checking that, the command would be list /LTM virtual all properties. So let me come down and see where is this command. This is the command. So if I just double click this, my the output of this command will be run, will show all the configuration on the device. So basically, when this file was created, this command was run on this device, and the configuration whichever was there, that was copied in, and I can view the output of various commands like this. All these commands output, I can see what is the configuration. This is as in similar to how you run on the device. You can go to network and see network related properties. You can click on system and go to system related configurations. Even at the Linux level, you can see the various options which are available. Um, any networking related configurations you can see in here. All these various options, various commands, you can see the output and analyze the output, analyze the configuration from here. Then comes diagnostic section. In this diagnostic section, you will have basically a set of vulnerabilities or issues with that specified version. Whichever version you are currently running on, all those issues will be listed. So for example, you are trying to troubleshoot a high CPU issue or high memory issue. So in here, you come to diagnostic section and just search for maybe CPU. So this will show you a set of articles or set of issues which are available and applies to this specific version. It might relate to what you are currently observing. You are observing a high CPU, so or high memory. Let me search for memory. So with respect to memory, I see this specific article. A known issue causes the chmand process to leak memory on the big IP. This might be the one which is causing high memory or memory utilization on your device. So basically, you need to go on details and search for that article to see if there is any recommended version. What is the recommended version? Upgrade to this version or later. So you can check this article and see if there is any workaround. If there is any workaround, you can try to implement that. If no workaround, you can try to perform the upgrade to whichever version is providing a fix for this specific issue. So likewise, there are different levels of diagnostic: critical, high, medium, low. All this you can find it. Even you can download all the specific issues on this version as your PDF or a CSV file. Then comes the file section. In this file section, you will be basically able to navigate through the different log files or different configuration files. If you just click on config, you can see the various configurations file. I want to open this file, just double click this. So basically this file will open up here. You can view the configuration, go to specific directories, and similar to this, in this section you have security. If ASM is enabled, you can see the ASM policies in here. Uh, then in your actual QK view, there is also, this is a dummy file. There will also be option for graphs. So you can basically view the utilization graphs, connection, how many connections are going in, how is it varying. All that data you can view and troubleshoot the issue according to your requirement. Even when you log a new case with the vendor, right? The TAC engineer also, when he collects this QK view, he uploads it to this iHealth portal. So you can even directly upload to your iHealth portal and give him the link, or tell him that with this user ID I have uploaded. So he will be able to search this and view your configuration. So this basically completes QK view section. We'll end it here for today. We'll continue the troubleshooting section tomorrow.